So today we're going to be doing the next part of this tutorial. We're going to be working on making the pattern head. So it's going to be looking something like this. And it's going to be a geometry nodes based solution. So let's get into it. We're going to make a new mesh, have a cube just to host the GeoNode system. Just put it there. Let's just call this pattern swirl. And go into geometry nodes. And this can be deleted. It's going to be a curve line is going to be how we're going to be doing most of this. So we have the curve line. Now we want to get this kind of spiral-y shape like we're seeing. So there's lots of ways of doing this, right? And also since it's very complex, we're not going to just do one of them. We're going to instance a whole bunch of them. So we're going to make a few of these different spiral patterns and instance them all kind of on the same spot so we can rotate and play with them together. So let's just first do one of them in the beginning. So we're going to be doing a set position node. And then before that, we're gonna do a resample curve. Let's do like 50 points. It needs to be quite high resolution. And then from here, we're gonna be doing a vector rotate node. So we vector rotate. That plugs in here. And it's gonna be rotating on the position vector of this. And then from here, the main trick is going to be using the spline parameter and piping that into the angle, using a math node to multiply it. If it's working. Why is it not working? Resample. We got to choose the axis. It's on the Z right now. That's the problem. So let's change the axis to this one maybe. Let's turn it on 0. Is this right? No, it's going to be this axis. Let's just say 0. Perfect. So now we're getting a spiral, which is good. And so now we can have these spirals spiral out. So we want to have this do a double spiral if we can. It's looking like it's going like this, maybe. Like this into this. Which is just kind of like a sine wave. But some of them are more like here. Right? So that's kind of that spiral, right? So we can do those spirals and then instance the other ones too. So we have to do a mixture of spirals. We have one coming like that, which is like a sine wave. These ones look like they're coming here out too. So that's kind of how we're gonna do it. And so what's nice is we can do this with a add here. If we clamp it, and say 0. Gotta see it. So if we go like 0, pop up a little bit, we can see how that will shift where it's spiraling. We also can add a ping pong node. It's like 0.2, 0. And now we can get this kind of look too. So these are all these kind of different ways of changing the spiral shape and everything. So we just say 0, it should be fine. Or say 1. So let's just see, minus 0.3. So this is kind of the main game right now, is just playing with these different views to figure out how we like it. So then let's do this here, and let's all change the center. So it should go up, I think, on the Z. There we go. So by moving it up, we now get that nice spiral at the edge. And then if we can reflect this, we might be able to do a double. Let me think about that. And we can do that really simply by taking a translate or transform geometry, right? We pipe this in. We're gonna do a join geometry. And I think if we scale this in the minus Z, there we go. See, now we're kind of getting a mirror of it, right? So if we change this, they will all kind of move together. Be minus x2. What's happening here? No. 1 minus. So it reflects twice. Nice. And if we do a set position before this, we can then also kind of smooth it out. So we're going to do a blur attribute. And we're going to do another set position. Take another position vector, put that value in here as a vector, and put it in here in the position. Maybe do like 5 iterations and make the weight less. Nice. I am liking it. So then we want to have it be like 6 of them, right? So we're saying 1, 2, 3, 4, 5, 6 exactly. So we can do this again, or we can just take this and instance this whole shape 3 times, or 2 more times, I guess. Actually, just do it 3 times. Let's do a curve circle, and we're gonna do 3 of them, right? So we know we're gonna have a triangle like that. I guess we need to change the orientation. So let's do a rotate, or I guess a transform geometry. Pipe this in, and let's rotate it on the Y, 90 degrees. Perfect. I guess if we did 6, we have a hexagon. That works. We can say instance on points. We know we have 6 points in a perfect hexagon orientation. Let's see how that looks. Great, we're getting there. So all of this right now is just one spiral. So let's group all of this. This is just one spiral, or spiral 1. So we grouped that all into one big node group called spiral 1. So that's all gonna be doing one spiral, and we're gonna be instancing it on this right here. So we're just gonna rotate them here. So rotate rotate instances, boom. And it's going to be ID, and we're going to see, what is it? Nope. The X value, so it's going to be a combined X, Y, Z, just do the X value. It's going to be this, piped in, and then it's going to be multiplied by something. So we're going to say multiply, and we know it's going to be multiplied by tau divided by 6. There we go, perfect. And the reason why that works is because we know that their tau is the full 360 rotation, and then we have 6 points, so that's how many times it needs to go. So I guess actually to keep it dynamic, if we want to change it here, we can do this. We can do an integer, pull in the math node and say divide, and we're gonna do 6 here, so it's the same number of points, and then whoops, 6 negative, interesting, okay. 6, and then this is going to be here, and it's going to be divided by 6, so this will be tau. This will be the same number, and if we change this, it will dynamically change. That's pretty cool, right? Let's pull out a value here. The one we want to play with is, I think, so this motion is working perfectly. So we're going to pull this out as a value and put it in here. This is going to be called the spiral amount, spiral driver. Boom. So we have this to play with, and that can animate and play with everything. We also have these endpoints of the spirals that we care about, which are these right here, right? These endpoints, which I think we can get if we take these instances, and if they're still splines, I think we can take the endpoints. So we can say spline to points, or instance on points maybe. And we take this. In our selection, we just went with the endpoint. So endpoint selection maybe. Let's see how this works. And let's say cube. Nice. Does this work? Yes. Huh. And there's also points there. Oh, because there's two ends. So then we can say not. Nice. This is some pretty janky Boolean math, but basically I just wanted to make sure that I could get to the middle point to be deleted. So I have the position where I guess if it's greater than minus 0.01, basically if it's not that exactly. So actually if it probably just did this and you see the selection, you can see how it's working, right? So it pulls out from the center as it gets smaller and smaller. Minus 0.01, and let's just keep this here. Boom. So now we have those selections. From there, we'll probably want to do another spiral. We have that spiral generator. This is a double spiral though. Is it a double spiral? No, it's a single spiral. It's a double spiral. You're gonna want to do singles. So let's rename this. This has been called double spiral. And then let's clone this and then say double spiral. There we go. This is double spiral. Boom, fake user, single spiral. And we'll say single spiral. Come back in. And then we know we just need it from back here, right? So then this can pipe through. Ignore the rest of that, and it should be good. Actually, if I just do, I think it's still 1, right? And then we do a float curve here. And we just change this orientation, it should work. And then if we do, we change this to go here, X, .01, 1. Now let's see how this looks. Yeah, I think that's working now. Nice. We fixed our single spirals. Now it's looking pretty good. And we can then instance them as well here on these points. So the single spirals are then coming here. Is it all the same? I guess it's actually the same rotation, which is easy to do. So if we take this rotation, which I guess could just be here, right? So let's delete that, rotate instances. And let's get this endpoint selection to be done. Whoops. Control G. This can just be the endpoint selector and then endpoint selector. Cool. That way it's more clean. There. And then this is the spiral. So Control G. And this is spiral rotation. Spiral rotation. There we go. Now it's way more orderly. Pop that in here. Pop that in here. How does that look? Nice. It's looking fantastic. That's what I have to say. So we can say join geometry. And we go here and here. cut that out, cut it here, pipe it. Nice. So we are getting somewhere. Nice. So I'm just playing around right here. What I added was another transform geometry and reflecting it on the y -1, so that way it's kind of inverted a little bit. I think it looks a little bit better. I'm more happy with it kind of spiraling that way. And then if we change these spirals, let's see how we compare the values actually. So we do a value here and a value here. Oops. Will it? No, it's not quite. It's kind of nice though. It's like a really easy way of kind of having multiple views. -1. Nice. So I think I have the main spiral pattern down. And I think this is kind of how I like it. So it's looking pretty good. So then let's do a... so this is kind of what I was thinking about doing. So now let's do... finish up that kind of general... that general kind of look. And so we're going to do that with doing a... I guess I can just use the curve to mesh and use the factor here, but it should be fine. So let's say float curve, popping this in here, here. .03 maybe. Set spline type, perfect. Nice. Okay, so that's kind of the main kind of effect for that. Nice. So I think this is the main effect, and the way we can then adjust it is you can layer this effect multiple times with different values on these two parameters. Let's talk through this one more time so you make sense of the effect. So we'll go over the full node group really quick. Okay, so we have over here the spiral node group. This is where all the magic is kind of happening. So inside of this, we're essentially taking a curve line, we're resampling it a bunch of times, and then we're setting a position with a vector rotate in order to then choose how it's spiraling out. So we can play with it with the ping pong and the math add and all these different things, but the main thing is using this factor, which goes from 0 to 1 along the curve, and multiplying it by a bunch of a much larger number, so it will spiral out above. So we'll keep on spiraling. We make sure to choose the correct axis when doing that, so it will work correctly. Then what we're doing is we're taking a transform geometry and then reflecting that effect across both. So we're gonna have this kind of like perfect, mirrored view of it. And that's gonna allow for kind of this clean transition in between the two things, which is pretty nice. So then we do that once for the double spiral and once for a single spiral at the edge. That way we're able to get this kind of like spiraling again at the tails of it, right? That's happening here. It's the same thing. This part's just deactivated. And then over here, we're taking the same thing kind of coming in, and it's all just the same. We're just doing the single set position, and that's kind of what we're doing. And maybe we're changing where the center of the rotation is on, right? So that way it's a bit further down. And honestly, that should probably be a parameter. So let's pull that out really quick. So if we say combine XYZ, we say -1. We have this coming in, and we call this curve spiral center, maybe. Nice. Let's pull that same one out too. No. Pop it in here. 1. Curve spiral center. There we go. So now we have 2 things to define that. Then we're instancing it along a curved circle, essentially to make sure we have everything make the most sense. So we can shift these up and around, and this kind of also impacts how the shape will look, right? So we can have it out like this, and that will change how it will pattern out, which is cool. And then we can also have it further in, so it's all kind of procedural. And we're using an integer to define the resolution as well as the rotation. And the rotation is being defined by basically just doing a simple math thing. So it's the ID for the number of indexes. So we have to go from 0 to 5, and we're multiplying it by the the radian rotation of what we want it to be. And that will work out. And then it's combined just on the x value. That way it's only rotating on the x, which is how it's all going to work out for us in this orientation at least. That same rotation value is being used in 2 spots, as we see right here. And then let's actually kind of clean this up a little bit. And we also made a little endpoint selector group right here. This endpoint selector was just a way to get only the endpoints of the curve to get these new kind of instances working perfectly. It was some, Boolean math to make it work with the position value to kind of like hack it together. And then over here, we join it all back together. And then we're going to use a new spline type to make sure it's smooth. If we do Bezier, it's going to be a bit rough. Catmull Romp keeps it a bit more smooth, which is nice. And we're using a float curve with the factor to set the radius of the curve to be smooth, which is nice. And that's kind of how the main effect is working. So that is the main effect. And now that we have it all in this kind of like geometry nodes input, where all these kind of factors are here, we can control it all off over here. It makes it really easy to use everything. Hope that makes sense, and hope to see you guys in the next part of the series. Thanks so much.
Augury.